Hello, Professor. I'm Zhang Wenxuan, and today I will present my project, use machine learning to predict the future sales of Xiaomi mobile phones. In this study, I applied machine learning models to Xiaomi's sales data to forecast feature turns and support smart business decisions. In the competitive smartphone market, let's begin. In this study, I used Xiaomi's monthly sales data from 2030 to 2024 to build 6 machine learning models. The models were evaluated using MSE, RMSE, and R-squared. Among them, XGBoost performed the best with an R-squared of 0.9891 and an RSME of 0.4590. Based on this model, the 2025 forecast shows a steady sales growth, reaching a peak in the fourth quarter. Overall, this model can support enterprise-size forecasting and help build more intelligent decision-making systems. Now, let me explain the problem background and my research motivation. The global smartphone market is highly saturated and growth is slowing down. The annual growth rate is now only 1.1%. In China, the largest market, the situation is similar. Shipments dropped to only 286 million units in 2022. As for Xiaomi, although it promotes itself as a cost-effective brand, it faces key challenges: shorter product life cycles and intense market competition. Therefore, my research motivation is twofold. First, improve the accuracy of sales value prediction. Second, overcome the limitations of traditional statistical methods by using machine learning. Next, let me introduce the objectives and the scope of my research. The main objectives are: first, to improve prediction accuracy of Xiaomi mobile phone sales. Second, to identify key sales drivers. Third, and to support real-time decision-making for the company. Regarding the data scope, I used the monthly sales data from 2030 to 2024 in China. I built and compared 6 regression models: linear regression, random forest, decision tree, SVR, KNN, and XGBoost. Finally, I used the optimal model to forecast Xiaomi's sales for the year 2025. This is the overall methodology of my study. I followed 5 main steps: data collection, pre-processing, modeling, evaluation, forecasting. The data was cleaned, standardized, and supplied 65% for training and 35% for testing. I used year and month as the core features to capture turns and seasonality. All 6 models were tuned and evaluated through a constant process, using MSE, RMSE, and R-squared for comparison. Here is the exploratory data analysis. First, Xiaomi's sales show a clear seasonal growth trend from 2030 to 2024, as we can see in the time series chart. Second, events like holidays and promotions cause obvious sales fluctuations. Finally, there is a weak link between economic search, popularity, and actual sales. As shown in the scatter plot, high popularity does not always lead to high sales. Those insights guided my feature selection for the models. Next, here is the correlation analysis and feature selection. From the heat map, we can see that Xiaomi's sales have a positive correlation with year and Oppo sales. There is also a negative correlation with search popularity, meaning more searchers don't always lead to high sales. Based on this, I selected year and month as the input features to keep the model simple, constant, and forecast on clear time-based patterns. Now, let's look at the model comparison results. I tested 6 models: linear regression, decision tree, random forest, SVR, KNN, and XGBoost. We used the 3 evaluation metrics: R-squared, RMSE, and MSE, and show in the table XGBoost achieved the best performance with R-squared of 0.9891 and RMSE of 0.4590, showing excellent no learning fatigue and very low error. In contrast, SVR performed the worst with R-squared less than 0, meaning it is not suitable for this prediction task. Next, here are the visualization results of the XGBoost model. In the top right chart, we see that the predicted sales closely match the actual sales. The trend lines are highly aligned. The histogram below shows that residuals are certaintied around 0 with no obvious bias, indicating the model has good accuracy. The scatter plot on the left also shows residuals evenly distributed, confirming that the model is stable and has stronger generalization ability across different sales levels. Here are the forecast results for 2025 based on the XGBoost model. As shown in the table, sales value is expanded to rise steadily quota by quota, with the highest sales reaching 20.4 million units in November and December during the major promotion season. Based on those results, I recommend giving priority to using XGBoost for future forecasts, as it is well suited to non-learning sales partners and can be easily updated with new data. In conclusion, XGBoost is the best model in the study. With excellent accuracy and stability, I recommend further parameter tuning and integrating it into business systems. There are some limitations. Economic cost factors were not included. The data size is small, and not deep learning models were used. In future work, I plan to explore deep learning, expand the data set, and develop a cost-sensitive prediction strategy. Thank you very much for listening.